the neural network topology will be modified to some extent and it will be trained. Okay, so instead of going for random initialization of the weights, what we can do is we can go for learn the weights by using the Boltzmann machines. Boltzmann machines can be used for learning the weights from the given data, and those weights can be used for initializing a deep belief network. Actually, you can see in this Boltzmann machine, you can see only visible nodes and hidden nodes. Okay, so by stacking this type of visible nodes and hidden nodes one after another, you will be able to build a deep learning model. And this pair of visible nodes and hidden nodes can be, when stacked, okay, that particular stack can be used for learning the weights from the given data. Means Boltzmann machines can be used for pre-training or initializing the weights of deep neural networks. Okay. Next comes autoencoders. Autoencoders will have a structure something similar to this. So there will be an input layer, one or more hidden layers, and then an output layer. But you can see as you look at the hidden layers, the number of nodes in the hidden layers are decreasing gradually until this particular layer, which is shown at the center, which consists of only 3 hidden nodes. And again, you can see on the right side of this, the center layer, it is something here the number of nodes are gradually increasing till the output layer. Okay, this is the basic version of autoencoder. Actually, there are many autoencoders like denoising autoencoders, contrast to autoencoders, then variational autoencoders, etc. This is the basic version of the autoencoder. And here, whatever is, because the dimensionality or the number of nodes are gradually decreasing from the input layer towards the middle layer, what will happen is when the input gets passed from the input layer through the hidden layers till the center layer, okay, so the dimensionality of the input is decreasing. So here you can see what is the dimensionality of the input layer: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When it comes to the next layer, dimensionality got reduced to 8. Next, it got reduced to 6. Next, it got reduced to 3. Means the autoencoder will be able to learn compressed representation of data. It will be able to compress the data. Means it is able to learn high-level features from low-level features. Okay, so in that way, autoencoder acts as a very, very good feature extraction technique like PCA. PCA is one of the dimensionality reduction technique. Okay, but PCA can only do PCA can find new features which are linear combinations of the original features, whereas autoencoder can find the new features which are non-linear combinations of the original features given in the input layer. Okay, so autoencoder is one of the very powerful feature extraction technique or dimensionality reduction technique. Okay. So this is about the autoencoders. Then another popular neural network which is frequently used with computer vision tasks is generative adversarial network. Okay, so here we have a generator and a discriminator. You can see here there are two models here actually, generator model and the discriminator model. What is the use of this generative adversarial networks? It is used to generate new samples that resemble the given dataset. Means GANs can be used for generating, for example, if it is images, they can be used for generating new images which are similar to the images given in the training data. It will be able to generate new images which are similar to the images given to it as input. If it is text, it will be able to generate new text which is similar to the text given previously. If it is video, it will be able to generate new video which is similar to the videos which is given as input to it. So GANs are designed to generate new samples that resemble a given dataset. How do they generate it? By understanding the underlying data distribution. By taking the input, they will try to understand the underlying data distribution. From that, it will generate the new data which is similar to the data which is given as input to it. So the generator is responsible. If you can see in this diagram, you have generator, discriminator. So the generator is responsible for generating the synthetic samples such as images, text or audio. So how does it generate this? Either from random noise or latent space representation. You can see noise, latent space representation. What is latent space representation? Latent space means it is nothing but hidden representation of the data. So it means the generator will try to learn the data distribution of the input, and by learning the data distribution, it will try to generate new samples which are similar to the input data. Okay, for example, if I have given many images of Modi, okay, or Prime Minister Modi for the generator, it will generate a new image which is similar to the original images of our Prime Minister Modi. Okay, so the generator will learn to generate the samples. And what is the discriminator? Discriminator is nothing but a binary classifier. Okay, it will take the images. It will take both the real images as well as the images generated by generator, and it will tell whether an image is real or fake. Real means it is an image or sample which is originally present in the input data. What is fake? Fake is an image or a sample which is generated by generator. So the discriminator will be able to tell whether a given input sample is real or fake. Okay. So the discriminator is trained both on real samples as well as the generated samples from the generator. So the training process of GAN involves a competition between this generator and discriminator. What does the generator try to do? It will try to generate as realistic samples as possible. Means the sample that is generated by generator should be as close or similar to the real sample. Okay, so it will try to fool the discriminator, while the discriminator aims to correctly classify real and generated samples. Means this generator will try to generate sample which is very similar to the original data samples. But and what does discriminator try to do? It will try to correctly identify whether any sample is real or fake. Okay. So these two components are trained simultaneously, and the objective is to improve the performance of both. Okay. So during training, the generator goal is to minimize the discriminator ability to distinguish between real and generated samples, whereas discriminator's goal is to maximize the ability to differentiate between real and generated samples. Okay. So where GANs are used? GANs are frequently used in various types of domains, including image synthesis, text generation, then music composition, video generation. You can see that deep fake, etc., where fake images or fake videos are being generated and circulated over internet nowadays. So those types of things are done by using GANs, generative adversarial networks. Okay, these are some of the neural networks, famous neural networks, which are frequently used. Apart from this, there are other famous neural networks also, like transformers, etc., which you might have already learned on the session on natural language processing. So today, let us focus on mainly on the neural networks which are used for computer vision. What is computer vision? Computer vision is nothing but a field of artificial intelligence. Okay, it's a subfield of artificial intelligence and computer science that focuses on enabling the computers to gain a high-level understanding of visual data, such as images and videos. Okay, so it involves developing algorithms and techniques that allow computers to extract meaningful information from visual inputs and make sense of the visual world. So we try to develop algorithms, techniques or systems which will be able to extract meaningful information from the visual inputs and make sense of this visual world. So the goal of computer vision is to replicate the human visual system's ability to interpret and comprehend the visual data. Okay, so what are the different tasks which come under the computer vision? It's like image recognition, object detection, then we have image segmentation, scene understanding, and image generation. Okay, so here for this computer vision, the first and very famous deep learning model which is developed is convolution neural networks. Okay, later on other types of models are developed like RCNN, that is region based CNN, mask CNN, retina nets, YOLO, etc. All these are advanced models which are developed based on this CNN architecture. So convolution neural networks are a class of deep neural networks. They are developed by taking inspiration from visual cortex of human brain. Okay, so here a convolution neural network is designed for processing structured arrays of data such as images. So you can see how CNN takes an image in the form of an array. Before we go into the details of this CNN, let me show you a small dataset, which is very simple and which is famous. Okay, whenever generally people teach about computer vision, okay, the convolution neural networks are the first topic which are discussed. And again in computer vision tasks, image classification is considered something a simple task when compared to other tasks like object detection or image segmentation or caption generation for images, caption generation for videos, object tracking. Among all these, image classification is a simple task. So here you can see one small data set is shown there, which is called as the MNIST data set. Okay, MNIST data set is nothing but the handwritten digits data set. So we have digits from 0 to 9. So if different people write these digits, okay, the photo or the image of that, a photo of that handwritten digit is taken and it is stored. Handwritten digits dataset. Okay, so in this MNIST dataset, actually how many images are there? There are 70,000 images of digits 0 to 9. And each image size is 28 by 28 pixels. Every image size is 28 by 28 pixels. And here you can see the pixels are, the images are grayscale images. Grayscale images means only we can find colors from white to black. Okay, white to black means you may also have some images in gray shades. So here you can see one small image, one digit, handwritten digit, which is described by 28 by 28 pixels. So here whatever is red, whatever is shown in the black color is the handwritten digit. Okay, all other pixels in this image are white. So 28 by 28 pixels. So when you store this data in computer memory, okay, it is a 28 by 28. We take a 28 by 28 array, and wherever you have a white color pixel, that is encoded as 255, and wherever you have black color pixel, it is encoded as 0. And any gray color pixel will have a value between 0 to 255. So this is how a handwritten digit will be. Okay, so what is the purpose of this data set, or for what use, for what do we do with this data set? A given the purpose of this data set is we need to develop a model, okay, which can correctly recognize the digit which is present in an image. Means if I give a handwritten digit image as input to the model, it has to specify which digit is present on the image. Is it 0 or 1 or 2 or 3, etc. Okay, so it comes under image classification. So here you can see there are some more handwritten digit images 137. Okay, and one hot encoding. Let us see what is meant by one hot encoding. One hot encoding is because we have 9 digits. Okay, so each digit is encoded as using 10 binary digits. Here you can see 1, 2, 3, 6. 9, 10. Okay, so if it is 1, okay, in the location corresponding to the digit 1, we put 1. All other digits will be 0 here. This is called one hot encoding. 3 means 0, 1, 2, 3. In this place we put 1, all other are 0. 7 means 0, 1, 2, 3, 4, 5, 6, 7. Here we put 1, all others are 0. Okay. So this is called one hot encoding. Why I am discussing about one hot encoding is now we are going to see about a small neural network model which can be used for classifying the handwritten digits. Okay. So here you can see the model. So how do we pass as input? First of all, whenever you have a handwritten digit as handwritten digits data with you, how do you pass this as input to the model? Okay, because we are discussing about the neural network models, the neural networks have an input layer, one or more hidden layers, and an output layer. Okay, you pass the data to the input layer. You can see this is the input layer because we have the image which is 28 by 28 pixels. 28 by 28 pixels means it is 784 pixels. Okay, these 784 pixels will be flattened and passed as input to the input layer. What is meant by flattening? First we pass the pixels corresponding to the first row. First 28 pixels will be passed to the first 28 nodes in the input layer. Next 28 pixel values will be passed as input to next 28 nodes in the input layer and so on. So how many nodes are necessary in the input layer? 784, which is nothing but 28 by 28. Those many nodes are necessary. Okay. So because it is difficult to discuss this concept by taking this large input data, means 784 pixels data, I have written handwritten digits only using 4 by 4 pixels. 4 by 4 pixels. You can see again we have a 6. I hope this is looking like 6 here. There are only 4 by 4 pixels. Okay. So this 4 by 4 pixels data generally it is a 2D structure. It will be stored in a 2-dimensional array. Okay, this is converted to 1-dimensional array in this form. You can see the first row pixel values are stored first. The second row pixel values are stored next. Third row pixel values are stored next. And last row pixel values are stored at the last of this array. As I already told you, wherever you have white pixel, it is taken as a value 255. Wherever you have a black pixel, it is taken as 0. Okay. So now this data is given as input to the input layer. This is the input layer in this particular neural network. And when you look at this neural network, I think you might have identified it is a feed forward neural network. There is one input layer, one hidden layer, one output layer. The number of nodes in the input layer, how do we know? It is equal to number of pixels in the image. In this image, we have 16 pixels. So in the input layer, we take 16 nodes. In the output layer, how many nodes are necessary? It is equal to the number of digits. The number of digits, that is 0 to 9. So how many nodes are there in the output layer? 10 nodes. And every node in the input layer is connected to every node in the hidden layer. Every node in hidden layer is connected to every node in the output layer. So this is called a feed forward neural network. So you can also use a feed forward neural network for image classification. Okay, but we have a small problem. This problem is, first thing is when you convert this 2D data into 1D data, what is happening? We are missing the spatial locality information. Means if a pixel is below another pixel or a pixel is above another pixel, okay, those pixels will not lie close to one another when you flatten. When you convert the data from 2D to 1D, the pixels which are one above the other or diagonally adjacent will not be adjacent in the 1D data. Okay, that is called we are losing the spatial locality information. The second problem is here the number of weights in this neural network is very large. If you look at this particular diagram, like how many weights will be there? Or how many learnable parameters this neural network has? Learnable parameters means all the weights in the neural network and bias. So how many weights will be there? You have 16 nodes in the input layer, 4 nodes in the hidden layer. 16 into 4, 64. Okay, those are the weights between input layer and hidden layer. Number of weights between hidden layer and output layer is 4 into 10, 40. So these are the weights. And every node in the hidden layer and the output layer is associated with a bias. What is bias? Bias is nothing but a threshold. Okay, we discussed about bias when we discussed about this perceptron. You can see, I think you can see the slide perceptron. So here we have something called bias, B. There we discussed if the weighted sum of the inputs is greater than or equal to the threshold or bias, it will generate 1 as output. Otherwise, it will generate 0 as output. Okay. So that is called bias. So every node in the hidden layer and output layer is associated with the bias. Okay. So all the weights and bias will be randomly initialized before you start training the neural network. So during training, what will happen? The neural network will adjust or update the weights and bias so that they reach optimal values at the end of training. Okay, if the neural network is able to learn the weight values and bias values properly, okay, it means it will be able to correctly associate between the given inputs and outputs. What is meant by correctly associating? Whenever I have given a handwritten digit image as input, okay, the neural network will be able to correctly tell which digit is present in the image. That is meant by correctly associating the given input to output. When it will be able to do that? It will be able to do that if the training, during the training process, if the neural network is able to update its weights and bias properly. Okay, now how many weights and bias it has to update in this neural network? How many weights are there? 16 into 4, 64 weights between input and hidden layer. Plus, how many bias are there in the hidden layer? 4. Every node is associated with a bias. How many weights are there between hidden layer and output layer? 4 into 10, 40. Plus every node in the output layer is associated with a bias. So 10 bias. So total number of parameters is 118. That is total number of weights and bias is 118 in this neural network. Means it should be able to correctly update these 118 weights and bias during the training process. Okay. So only then the neural network will be able to perform this image classification task properly. Okay, so this is actually a very small neural network. As the in the feed forward neural network, actually there may be many more nodes in the input layer, many more nodes in the output layer, and there can be 2 or more hidden layers, and each hidden layer may have huge number of nodes. Okay, then what will happen? The number of parameters that the neural network has to learn or update increases tremendously. Okay, so these are the two problems we have seen with the multi-layer perceptron. One is it has a large number of parameters which it has to properly update during the training process. Second is when you pass the input data, that is image data is input to the input layer, spatial locality information is missing. That is the pixels which are one above the other in the original image, or pixels which are diagonally closer in the original image, okay, will be spread out when you convert the 2D data to 1D data. That will be lost. So these are some of the problems of using multi-layer perceptron for image classification. Okay. So before we go into the convolution neural network, let me show you one more thing. What will be done whenever an input image is given as a handwritten digit image is given as input to the input layer. Like how we have discussed in the case of feed forward neural network. I told you the input passes from the input layer to the hidden layer. From the hidden layer, it passes to the output layer. Okay. So what does the output layer generate? In this case, the image classification is, so each output layer node will be generating a probability. Each output layer node. Excuse me. I think someone's mic is unmuted. Please mute it. What does the output layer generate? The output layer will be generating a probability value. Means when this particular image is given as input to the input layer, okay, each of the output layer nodes will be generating a probability. Okay, whichever node has generated the highest probability, that particular digit will be given as output. Means you can see in this, the node corresponding to digit 0 has given the highest probability, 0.9. Means now what is the output of this multilayer perceptron for this input? This multilayer perceptron says that the digit on this image is 0 because the node corresponding to 0 is giving the highest probability as output. But it is false, but it is not correct. Actually, which node should generate the highest probability? Node corresponding to digit 7 should generate the highest probability. Okay, it means the neural network has made error. Definitely neural networks will make errors because it is not yet trained. After it is properly trained, the number of errors made by the neural network will be very, very low. Okay, so now what should we do whenever there is an error? How do we know it is an error? Because we know that in this case, except the node corresponding to digit 7, all other nodes should generate probability 0. Only the node corresponding to digit 7 should generate the probability 1. Okay, but that is not the case. The actual probabilities and the predicted probabilities are different. What are the actual probabilities? All these should be 0. Node corresponding to 7 should generate probability 1. Again, 2 zeros. That are the actual probabilities. But these are the predicted probabilities. They are different. Okay. Now, using these actual probabilities and predicted probabilities, we compute loss or error made by the neural network. Okay. And that loss is called as categorical cross entropy loss. It is given by this formula. In the case of classification, we generally use loss functions like, if it is binary classification, we use binary cross entropy. If it is multi-class classification, we use categorical cross entropy. Its formula is given by minus sigma I yi into log yi hat, where yi is the true probability, actual probability, yi hat is the predicted probability. Okay. In the previous example, you look at the slide, we have given something called expected output and predicted output. Means if the multilayer perceptron has done, if the multilayer perceptron has given the correct output, what is the correct output? All the nodes corresponding to 0 to 6 should generate 0 as 0 probability. The node corresponding to 7 should generate 1 as probability or 1 as output. 8 and 9 again should generate 0 as output. I think you understood that here all these values represent the probability values. Okay, if it has given the correct output, then the expected output and the predicted output will be same. Okay, then if you substitute these values in the cross entropy function, you will get a loss value of 0. Okay, 0 into log 0. 0 into log 0 should be taken as 0. Okay, multiplication with 0 should be taken as 0. 1 into log 1. Log 1 anyway is 0. So 1 into log 1 is again 0. Okay, so you'll get loss as 0 if your multilayer perceptron has given correct output. But in our case, what has happened in this particular example, our multilayer perceptron did not give the correct probabilities as output when this image is given as input. Okay, it means it is making some error. We need to compute the loss. Okay, so here, when you look at the bottom values, expected output and predicted output, expected output is the true probability values that are to be returned by multilayer perceptron. And this 0.9, 0.1, etc. are the predicted probability values. So if you substitute these in this equation, you'll get a loss like this. How do you substitute? 0 into 0 is actual probability, 0.9 is predicted probability. So in this equation, yi is actual probability, yi hat is predicted probability. 0 into log 0.9 to the base 2. See here the logarithm base is 2. Okay, 0 into log 0.9 plus 0 into log 0 plus 0 into log 0 plus 0 into log 0 and so on. 1 into log 0.1. So this is the error. So whenever we get error, what will happen? This error will be used for updating the weights and bias of the neural network. So weights and bias of the neural network are called as the parameters of the neural network. Okay, so we do not directly use the error. What we use is we take the derivative of the error function with respect to weights and bias, and those will be used for updating weights and bias. Okay, so I'm not going into the details of how weights and bias are updated using the gradient or derivative of the error function. So that will come under the optimization techniques. Like we need to discuss about gradient descent method, or stochastic gradient, or mini batch gradient descent method, or we have other optimization techniques like AdaGrad, etc. So all these are the algorithms which are used for updating weights and bias, okay, using the error generated. So this slide shows us one more feed forward neural network, but here the only difference is the number of nodes in the input layer is more. In the input layer we have 784 nodes, and we have one or more hidden layers. Okay, here we have 2 hidden layers. Each hidden layer has 5 to 1 nodes. In the output layer, how many nodes are there? 10 nodes are there. So now how many parameters will be there in this neural network? 784 into 512. 784 into 512 plus 512. What is this 512? It is bias. Bias of the first hidden layer. 512 into 512 plus 512. This plus 512 is the number of nodes in bias of the second hidden layer. Lastly, 512 into 10. Okay. So how many parameters are there in this neural network? 6,69,706. These are the number of parameters. So you can see properly updating these many parameters it will take a lot of time for the neural network to train, because 6,69,706 parameters are to be updated such that they reach their optimal values. Okay. So that is the problem with the multi-layer perceptrons. Okay. So it suffers, that is updating the parameters take a large amount of time. Second is multi-layer perceptrons are prone to overfitting. What is meant by overfitting? Their performance may be very good on training data, but when you apply this neural network on test data, performance may degrade. Okay, and multi-layer perceptron does not exploit the spatial locality in the images. Okay, in order to overcome these limitations, the convolution neural networks are developed. Okay, so convolution neural networks consists of less number of parameters when compared to the multi-layer perceptron, and they are less prone to overfitting, and also they will exploit or make use of spatial locality in the images. Okay, so when you look at this convolution neural network, so I want to discuss this convolution neural network in detail, because all other neural network models, okay, which you will be using for computer vision, like it can be RCNN, region-based CNN, fast RCNN or faster RCNN, and mask RCNN. Okay, all these in order to understand them, the basic you need to understand this the basic version of the CNN, the normal CNN model. Okay. Similarly, even if you go for RetinaNet or if you go for YOLO models also, you will be better understand them when you properly understand the CNN model. So what is CNN? Here you can see. Previously, I have shown a multi-layer perceptron for this handwritten digits recognition. Okay. So here you can see there is one input layer, hidden layer, output layer. And every node in the input layer is connected to every node in the hidden layer. Okay, now we are going to see a CNN model for the same purpose. Okay, but the digit we are taking is the number 6. The input image we are taking is 6. So here the 6 is represented using 4x4 pixels. In order to simplify the explanation, instead of taking 28 by 28 pixels, we have only taken 4x4 pixels. Okay. So whatever is shown in the black color, that is the digit. Those are the pixels corresponding to the digit. All the pixels are white in the image. And you can see the boundaries of these pixels are colored. Okay, the boundaries are colored. You can see some pixels boundaries are red, some pixel boundaries are blue, some are green, and some are yellow. Okay, why I have colored the boundaries, you will understand shortly. Okay, so this is the original image. Now look at the neural network which is beside it. We have the input layer, hidden layer, and the output layer. But the one thing you have to remember is or understand is not all a node in the input layer is not connected to every node in the hidden layer. You can see the first pixel, first node in the input layer. Okay, it's only connected to the first node in the hidden layer. It's not connected to other nodes in the hidden layer. Okay. Okay, now what will happen? Actually, what is happening is when you look at the hidden layer nodes, okay, the first hidden layer node only will focus on the top left 4 pixel values. The second hidden layer node will focus on the top right 4 pixel values in the image. The green color node will focus on bottom left 4 pixel values. Yellow color node will focus on bottom right 4 pixel values. Okay, what is the use in doing that? Each node will try to identify a feature in one part of the image. Means the red color hidden node will try to identify some pattern in the top 4 pixels in the image. The blue color node will try to identify some pattern in the top right 4 pixels in the image. Green color node will try to identify the pattern in bottom left 4 pixels in the image. Yellow color node will try to identify the pattern in bottom right 4 pixels in the image. Okay, that's why they are connected in that way. Okay, now even if you flatten this data into 1D data, you can see this is a 2-dimensional data which is converted into 1D data. First 4 pixels are shown here in the first 4 values in this 1D data. Next 4 pixels, next 4. Next 4 pixels in this way. Even if we convert the data in this way, because of these interconnections between the input layer nodes and the hidden layer nodes, okay, spatial locality is not lost. Okay, spatial locality. What is means by spatial locality? Pixels which are close to one another, either horizontally or vertically or diagonally. Okay, they are analyzed by the same node. They are analyzed by the same node. So spatial locality is not lost. Okay, that is one of the big features of this convolution neural networks. Okay, the same diagram, the input layer and hidden layers, they are shown here. Only thing is hidden layer nodes are shown in the form beside one another here. Okay, these 4 pixels will be analyzed by this first hidden layer node, next 4 pixels by next hidden layer node, and so on. Now, so what is difference between the multilayer perceptron and CNN? CNN is sparsely connected. Sparsely connected means you can see some connections are missing here. A node in the input layer, if you take the first node in the input layer, it is only connected to first node in the hidden layer. It is not connected to other nodes in the hidden layer. So that's why we call it is sparsely connected. Whereas multi-layer perceptron is densely connected. Okay. And each hidden layer node only sees a part of the original image. You can see the red color hidden layer node. These colors will not be there. Actually, colors are only given here in order for us to understand clearly. Okay. It means the first hidden layer node only focuses on the top left side of the image. The top left hand side of the image. The second hidden layer node only focuses on top right side of the image, right part of the image. Okay, so in that way, each hidden layer node only sees a part of the original image. It's called locally connected layer. Okay, each hidden layer node finds patterns in one of the 4 regions of the image. Each hidden layer node finds the pattern in one of the 4 regions of the image. Okay, then after finding the pattern, what does the hidden layers do? They pass those patterns to the output layer. Okay, the output layer, what it does is it combines those patterns which are passed from the hidden layer, and it will try to discover the digit which is present in that image. Okay. So this is how a convolution neural network will generally work, but it is not as simple as we have seen here. Okay. In order to show the sparsely connectivity, I have shown this diagram, but a convolution neural network will consist of special type of hidden layers called convolution layers and pooling layers. Okay, that we are going to see next. Okay, how, like we have discussed previously, these CNNs are developed by taking the inspiration from visual cortex of human brain. You can see if we look at the brain. Okay, the neurons which are present at location V1, whatever is labeled as V1, okay, they will identify very primitive features. Primitive features means whenever you look at a man or whenever you look at any object, okay, the neurons which are present at V1 will be able to identify the edges and lines in that image. Neurons which are present at the part V2 will try to identify the shapes present in that object. Neurons present in V4 will try to identify any object, like for example, if it is human face, okay, it may try to identify like eyes, nose, mouth, etc. V4. And if you take the neurons present which are labeled IT, the neurons which are present there, they will be able to recognize the actual face. Means is that face belongs to a man or woman, who the person is. That will be recognized by neurons present in the location IT. It means what is happening? Neurons which are present at V1 are detecting primitive features, whereas as you move forwards, okay, the neurons which are present at IT are detecting high level features. Okay, from the primitive features, okay, what is happening? A little bit more high level features are built at V2. From the features detected at V2, still abstract or higher level features are detected at V4. Finally, at IT, the actual person is recognized. Okay, this is how it works in the human brain, in the visual cortex of the human brain. The same thing in the similar way, a convolution neural network will be working. Okay, so let me show you the diagram. I want to show you this diagram, then go into the details. You can see there we have a cat image. Okay, this cat image passes through a layer called convolution layer. Okay, where it consists of an activation function called ReLU activation function. Previously, when I talked about perceptron, I told what is meant by activation function. Activation function is a function which will be applied by an artificial neuron on its input to generate some output. Okay, so here the image will be passed through the input layer to the convolution layer, which is then passed to pooling layer. Pooling layer means it can be max pooling or average pooling, etc. Again, we have a convolution layer, pooling layer. Lastly, what do we have? We have something called fully connected layer. The data will be flattened and it is passed to fully connected layer. Okay. In the fully connected layer, the last set of fully connected layer means it is something like our fully feed forward neural network will be there here. Okay, fully connected layer means. Okay, you can see every node is connected to every node in the next layer. At the end, we have output layer. At the end of this fully connected feed forward neural network, we have an output layer which will generate the class label. In this case, means does the image belong to a cat or a dog? Okay, this is how the architecture of a CNN will be. So you can see input layer is common to any neural network. Output layer is also common. The only thing is hidden layers are changing. Here, hidden layers are a special type of layers called convolution layers and pooling layers. Convolution layers are responsible for identifying the features present in the image. And pooling layers are responsible for dimensionality reduction. Okay. So now let us see how the convolution layers will work. Okay. So here, if you take this 6, again, if you take the image of handwritten digit 6, described using 4x4 pixels. Okay. What does this convolution layer do? It will move a filter on this image. Okay, in order to identify some pattern. What is the use of filter? There are filters. Filters are something which are used in image processing, which are used to identify specific type of pattern. Means we may be having a filter which identifies vertical edge. We may be having another filter which identifies horizontal edge. We may be having another filter which will be identifying the blobs. Okay, blobs means pixels which are having common color. Similar. In that way, in image processing, different filters are used for identifying different types of patterns or features in the image. So here, what does the convolution layer do? It moves a filter on this image. So first filter is positioned on top left corner. You can see whatever is shaded with yellow color. Okay, those are the 4 pixels on which we position the filter. What does when you position filter on top left 4 pixels, what will happen is we simply take a product of position wise product of the filter value and pixel value, and we add them. Means 1 into 0 plus 1 into 1 plus 1 into 1 plus 0 into 0. Okay. Sum of products of the pixel values with the corresponding filter values. Okay. So 1 into 0 plus 1 into 1 plus 1 into 1 plus 0 into 0. So we got some value, right? Next, what do? We move the filter. Filter is moved right side by 1 position. Now the filter will be positioned here. The same operation again we do. We take a sum of products of pixel values with the filter values. Next, again it is moved by 1 location. Again it is moved. In that way, we go on moving the filter from top left hand side of the image to bottom right hand side of the image. Okay, we got some values, right? You can see 2 0 2 0 2 1 1 0 1. Okay, these values are shown here in the form of a 2D array. Okay, that is the output of a convolution layer. Okay, it is also called as feature map. That is called feature map. Okay, now after we get the output from the convolution layer, this is the feature map, right? After we get the output from the convolution layer, an activation function is applied on these values. What is the activation function that is applied? Generally, recently, the most popular activation function is ReLU. What does ReLU do? Whenever the value in the feature map is greater than 0, it will generate the same value as output. If the value in the feature map is less than 0, less than or equal to 0, it will generate 0 as output. If it is a positive value, same value will be generated as output. Otherwise, 0 will be generated as output. Okay, but in our feature map, what is happening? All the values are either 0 or positive. It means ReLU activation function, even if you apply ReLU activation function on these values, you get again the same values as output from the ReLU activation function. Okay, I think you remember this diagram. The image is passed from the input layer to the convolution layer. On the convolution layer output, what we are applying? ReLU. Okay, the output of this is then passed to the next layer called pooling layer. Okay. Now, before we go into the next slide, how do we know the size of the feature map? How many values do we get? Whenever you pass a filter on the pixels of the image, how many values will be generated as output in the feature map? The feature map size is given by the formula n minus f plus 1 into n minus f plus 1, where n is the size of the image. That is the number of pixels in the image, n by n image, okay? F is the size of the filter. Okay, what is the size of the image? 4. 4 by 4 images it is. So 4 minus 2 plus 1 into 4 minus 2 plus 1. That is 3 by 3. We got a feature map of size 3 by 3. So here in this slide, after we get the feature map, as I already told you, when you apply the ReLU function, we get the same values as output. As because all the values are either positive or 0. Okay, next. Previously we have seen that when you move the filter, by how many positions the filter is moved? Filter is moved right side by 1 position. Okay, actually you can move the filter by any positions to the right side. So now in this particular slide you can see that the filter is moved right side by 2 positions. First, filter is positioned on top left hand side 4 pixels. When you put it in that way, you get 2 as output. Next, filter is moved right side by 2 positions. Then you get 2 as output. Then it is moved down by 2 positions, 2 pixels. Again, right side by 2 pixels. Okay, I think I did not put that one. Right side by 2 pixels. Okay. Now, by how many pixels should we move the filter? Should we move the filter by 1 pixel or 2 pixels? Okay, it depends upon how accurately we want to identify the patterns present in the image. For example, if this filter is aimed at finding vertical edges, okay? If you do not want to miss the vertical edge, even if it is present at any position in the image, you need to move the filter by 1 position. If you move the filter by multiple pixels, sometimes you may miss certain patterns present in the image. Okay. Now, how does this now? What are the values we got? 2, 2, 2. I think the next value will be if you position this filter on the last 4 pixels, you will get the value as 1, 0, 1, 1, 0. Okay, 0 into 0 plus 1 into 1 plus 0 into 1 plus 1 into 0. It is 1. You get 1 as output on the last 4 pixels. Okay, now what is the filter map we get then? What is the feature map we get then? Feature map is 2, 2, 2, 1. See, this feature map is shown here, 2, 2, 2, 1. Now, how does this feature map is related to this input layer and hidden layer? Okay. Okay, now, what is the filter size? Please focus properly here. What is the filter size? Filter size is 4. Okay, filter size is 2 by 2. Now, how does it look in actual convolution neural network? 2 by 2 filter means actually there will be 4 nodes in the hidden layer. 4 nodes in the hidden layer. 2 by 2 filter means 4 values, right? 4 nodes in the hidden layer. The values of this filter are nothing but the weights of the connection between input layer and corresponding hidden layer. These 4 nodes will generate the values of this feature map 2, 2, 2, 1. Okay. Now, what are the values of the filter? You have seen the values of the filter are 0, 1, 1, 0. What are 0, 1, 1, 0? 0, 1, 1, 0 are the weights of the connection between the input layer node and the hidden layer node. Means W1 is 0, W2 is 1, W3 is 1, W4 is 0. Again, in the blue color node are the same. W1 is 0, W2 1, W3 1, W4 0. Okay. And how do we got these values of the filter? Actually, when we started discussing about this convolution layer, we have taken some values in the filter and we applied it on the pixels of the image. Okay, but in the convolution neural network, what will happen is actually you should only define the size of the filter. Means I want to take it 2 by 2 filter. Okay, the values in the filter will be randomly initialized at the beginning.
Okay.
It need not be 0, 1, 1, 0. It can be something like 0.1, 1.2. It can 0.1, minus 0.1. In that way, values of the filter will be randomly initialized. What is meant by values of the filter? They are nothing but the weights associated with the connection between input layer and the hidden layer. Weights are randomly initialized, right? In the neural network, when you start training, weights will be randomly initialized. Means values of the filter will be randomly initialized. But by the time the convolution neural network is trained, completed the training, these weights will reach their optimal values. What are meant by optimal values? These weights will get their optimal values such that they will be able to identify one specific type of pattern from the image. For example, if W1, W2, W3, W4 get some values, okay, such that they will be this hidden layer nodes, okay, will be able to identify some vertical edge from the image. Okay. So here one more important point is, you can see all the hidden layer nodes are sharing weights. Means the weight of connection between this red pixels in the input layer to red color node in the hidden layer, W1, W2, W3, W4. These values will be same with the blue pixels in the input layer to the blue color node in the hidden layer. Weight sharing. All the weights will be weight of the connections between input layer to red color node will be same as weight of connection between input layer to blue color node. Similarly, weight of connection between input layer to green color node also will be same. So they are sharing weights. But in the multi-layer perceptron, what will happen? All the weights are different. There will not be any weight sharing. What does this weight sharing says? Weight sharing is because what is our aim here? Our aim is these 4 hidden layer nodes have to detect a particular type of pattern in the image. If it is present in top left hand side, top right hand side, bottom left hand side, or bottom right hand side. For example, my aim is to detect a vertical edge. If it is present in top left hand side, top right hand side, bottom left hand side, or bottom right hand side. Okay, that will be possible only if all these 4 nodes share the same weights. They will be able to detect the same pattern. Okay, so what is feature map now? Feature map is nothing but, I think you might have understood what is values of a filter. Values of a filter are nothing but weights of the connection between input layer and the hidden layer in a convolution neural network. What is feature map then? Feature map values are nothing but output of convolution layer nodes. Feature map values are the values generated by the nodes in the convolution layer. Okay, so this is about how this filter and feature map relate to the actual neural network. This we have already seen that ReLU function will be applied on the output of convolution layer. On the output of convolution layer, which function is applied? ReLU. What does it do? Whenever the output of convolution layer is positive, it generates same values output, otherwise it generates zero as output. Now, when it comes to filters, actually here, the filter values will be learned during the training process. CNN will learn the filter values during the training process. But in image processing, prior to the development of these CNNs, people used to manually define the filters. Means certain filters are known to detect certain type of patterns. Okay, they used to manually give that filter and apply that filter on. Means the filter is defined by human beings. Okay, and it is applied on the images to detect some patterns. So what filters? There are certain filters like Sobel filter, Prewitt filter, which detects horizontal edge. We have Sobel filter, Prewitt filter, Canny filter, which detects vertical edge. Okay, there are certain filters which detect blobs, like Laplacian or Gaussian. Certain filters which can remove the noise, like median filter. Okay, this type of filters they used to use. on images in the image processing field by people who are working on image processing field. So you can see Sobel filter has these particular values for detecting the edges. Okay, Gaussian filter has these values. So these should be manually given by us if we are not working with CNNs. But in the CNN, what will happen? Filter values also will be learnt by it. Filter values are nothing but the weights of the connection between input layer to convolution layer. Okay. Now, the next thing is actually in this particular convolution layer, how many nodes are there? There are 4 nodes. Okay, all these 4 nodes are sharing the weights. Means all these 4 nodes can detect the same type of pattern, but from different locations in the image. Means, so for example, all these 4 nodes can detect only vertical edge, but from different locations in the image. Is it enough to detect vertical edge only for recognizing a person? No. Okay, we should be able to detect horizontal edges. We should be able to detect blobs. And then in the next phase, these edges, blobs, and should be combined to detect the organs. Then the organs should be combined to detect the person. Means it is not enough to detect one type of pattern. We should be able to detect different types of patterns. That's why there will be multiple sets of convolution nodes. Here there is one set of convolution nodes which are sharing the weights. Similarly, there may be another set of convolution nodes which are sharing another set of weights. Okay, in that way, there will be multiple sets of convolution nodes. In this diagram, they are showing. There is first 4 set of nodes which are sharing same weights, another 4 set of nodes which are sharing some other weights. Okay, their weights are shown on the right hand side in the form of filter 1, filter 2. In that way, there may be any number of sets of nodes in the convolution layer. So what is the use of convolution layer? For detecting the patterns present in the data. Okay. So next, here we have shown in the image, for example, if the butterfly is in here or in another location or another location, wherever it might be present, we need to be able to detect it. Okay, that is possible by weight sharing, because of the weight sharing. So this is about the convolution layer. Then what about pooling layer? We have already seen this architecture. Input is passed through the input layer. It is sent to convolution layer. Convolution layer, on convolution layer output we apply ReLU, which is passed as input to pooling layer. Pooling layer output is again passed to convolution layer. Again we have pooling layer and so on. In that way we have a stack of convolution and pooling layers. Why we need a stack? Why not only one convolution and pooling layer? If there is only one convolution and pooling layer, only one level of features will be detected. Means primitive level features only will be detected. But it is not enough to detect only primitive level features. Okay, primitive level features can be combined to form some high level features, which again in turn are combined to form still higher level features. Okay, that's why we need a stack of convolution pooling layers. Okay, so now, okay. So here I will show you like why we need a stack of convolution and pooling layers. This image is taken from a popular CNN model called VGG19. VGG19 is a popular CNN convolution neural network developed for solving a challenge, ImageNet challenge. Okay, it's a computer vision challenge which is conducted from around 2010. The aim of the challenge is there will be having some tens of thousands of images in the dataset, and the people who are participating in the challenge has to develop a model, and the model should be able to correctly classify each image present in the dataset. Okay, that is called ImageNet challenge. Okay, VGG19 is one convolution neural network which is developed as part of that challenge. So here actually we are seeing the output of these different CNN layers in the VGG19. So we have layer 1, layer 2, layer 3, layer 4 and layer 5. So layer 1 detects the primitive level features, okay, like edges. Layer 2 detects you can see layer 2 detects corners. Layer 3 detects the organs like mouth, eye, chin, etc. Okay. Layer 4 detects complex parts of the face. Finally, layer 5 will be able to detect the image, directly recognize the image. Means whether it is a human face or car tire or animal face, etc. So that's why we need a stack of layers, not single convolution and pooling layer. A stack of convolution and pooling layers are necessary. We can see the output of layer 5. So this is the original image which is shown on the right hand side. This is the image which is recognized by the layer 5. Okay. So we already discussed about stride. Lastly, let us see what is meant by pooling layer. What does the pooling layer do? Till now we have seen what is convolution layer. Now comes pooling layer. The pooling layer takes the output of convolution layer as input and applies a filter on it. So suppose this is the output of the convolution layer. Okay. So we are applying a 2x2 filter on it. So here, which type of filter we are applying? We are applying a filter which detects maximum value. 2x2 filter. What is the use of this 2x2 filter? It has to identify the maximum value on the pixels on which it is applied. So if you take 1329, the maximum value among these 4 pixels is 9. In 2111, maximum value is 2. In 1356, it's 6. And 2312, the maximum value is 3. Okay, pooling layer will be applied on the pixels of the feature map. Yes. Pooling layer will apply a filter on parts of the feature map to identify some or extract some value from that part. So there are different methods of applying the pooling. Max pooling, average pooling. Max pooling will take the maximum value from the values on which it is applied. Average pooling will take the average value. Okay, what is the use of pooling layer? Pooling layer is used to do the dimensionality reduction. You can see this is the actual convolution layer output. It is 4x4 size output. Means how many 16 values are there. After applying pooling layer, what has happened? They are reduced to 2x2. Means only 4 values. That is pooling layer is able to do dimensionality reduction. Then don't we lose any information? We don't lose much information because pooling layer is able to identify the most prominent pattern. For example, these values 1329 correspond to the presence of a vertical edge in a part of an image. Okay, so wherever you have 9, it means that is the location where the vertical edge is prominent in the image. Okay, wherever you have 1, it means the vertical edge is not so prominent in the image. So only the prominent features will be identified and retained through pooling. Okay. So this is in this we are showing the max pooling and average pooling. This is max pooling, sorry, max pooling applied on 2 different feature maps. Okay, this is about a convolution layer, pooling layer. At the end, what do we have? In the architecture of a CNN, after we have convolution layer and pooling layers, at the end we have fully connected layer. Okay, data. The output of last pooling layer will be flattened. Flattened means from a 2-dimensional data or 3-dimensional data, it will be converted to 1D data, 1-dimensional data. Flattening means. And then it is given as input to fully connected layer. Because in the fully connected layer, you can see, you need to give the data in 1D form. See how it is converted. For example, this is the output of pooling layer. It is converted to 1D form and given as input to fully connected layer. In the fully connected neural network, which is at the end of the CNN, okay, the last layer is output layer. Output layer will actually generate the output. Okay, this is about the CNN architecture. Finally, I want to conclude this by showing how CNN can be used for text classification. Actually, CNNs are very popular for computer vision tasks, but you can also apply them for text classification also. Okay, 1D CNN will be used, 1-dimensional CNN. What does it do? For example, if you take Here we are seeing sentiment analysis. Example for sentiment analysis. We are taking a review. Let us assume this is the review. I like this movie very much. Okay, we need to identify the sentiment of this review. Is it positive or negative? Okay, so now because this is text, we cannot directly give as input to the neural network. Every neural network expects the input to be in the form of numbers. Even in the case of image, what did we do? We converted the image into pixel values 0 to 255 and then given those values as input to CNN. Similarly, in the case of text also, we cannot directly give the text as input to neural network. The text has to be converted into numbers. Okay, one way of converting text is every word in the text can be converted to single number, or every word in the text can be converted to a vector of numbers. Okay, in this particular example, every word in the text is converted to a vector of 5 numbers. Okay, 5 numbers. You can see I is converted to a vector of 5. Actually, values are not shown here, only dimensionality is shown. I is converted to vector of 5 numbers, like is converted to vector of 5 numbers, and so on. Okay, so by converting in that way, you will be able to convert text to numbers. Okay, that is what is done in word embeddings. Okay, madam, in the natural language processing session, madam has discussed about this converting text to vector representation. Okay, that is called word embeddings. We have certain built-in classes available in Python which will allow you to convert the text into vector representation. Okay, after converting the text into vector representation, now CNN can be applied. See here in the second, you can see maroon color, red color, dark green, green, okay, and brown and yellow color. Okay, what does these represent? This maroon color and red color represents filters. Filters of size 4 by 5. 4 by 5 filters. 2 filters of size 4 by 5. How do we, each filter is moved on this vector representation of the text. Like how we moved the filter in the case of images. Similarly, if you take maroon color filter, okay, it has 4 rows, 5 columns. It will be positioned on first 4 rows and 5 columns of this vector representation of this text. Next, it will be moved down by 1 position. It will be positioned on second row to second, third, fourth, fifth row and 5 columns of this vector representation. Next, it will be positioned on third row to third, fourth, fifth, sixth. Next, it will be positioned on 4, 5, 6, 7. In that way, the filter is moved. Because the filter is moved down by how many times? Filter is moved down by 1 position how many times? 1, 2, 3. 3 times. Beyond this, we cannot move the filter further down because we do not have any further values in the input. 4 times it is moved. So every time the filter is positioned on a part of this vector representation of the text, we get 1 value as output. Okay, so how many values will be produced as output when you move the filter on this vector representation? 4 values will be obtained. Similarly, when you move the red color filter, here colors are given to show that they are different filters, not same filter. Okay, from red color filter is moved on this vector representation, you get 4 values because it is moved downside by 4 times. Okay, next dark green filter, its size is different, 3 by 5 filter. When it is moved, we get 5 values. Light green filter, 5 values. Then brown filter, how many times it is moved? 6 times it will be moved. It can be moved down 6 times, 6 values again. Yellow color filter also it's 6 values. Okay, now this is the output of whatever issue I'm pointing to. These are the outputs of convolution layer. Okay, these are the filters of the convolution layer. After you get the output of convolution layer, you apply max pooling. Max pooling means what? It will identify maximum value among these 4 values. Similarly, it will identify maximum values among these 4 values. It will identify maximum value among these 5 values. So you get max pooling, you get these values. Okay. The output of this max pooling layer is concatenated and given as input to fully connected layer, which is at the end of the convolution neural network. What does the fully connected layer do? It will take this as input and generate the output. What is the output? Output is sentiment, either positive or negative. So in the output layer, there are only 2 nodes. Okay, each node will generate a probability. If the sentiment is positive, the node corresponding to positive sentiment will generate high probability, and the node corresponding to negative sentiment will generate low probability. In that way, you can also use CNNs for text classification. Okay, which type of CNN should be used? 1D CNN should be used. If it is images, what type of CNNs we use? We use the 2D CNNs. If it is grayscale images. If it is colored image, we use 3D CNN. Okay, this is how CNNs can be used. Actually, there are, I think, many more topics to be discussed, but Madam, shall I stop or continue?
Hello.
Madam.
Shirisha.
I completed CNN, ma'am. Shall I stop now?
Yes. We'll start
Okay,
validation so that. Thank you.
Okay, ma'am. Thank you so much. Thank you.
Very eager to leave, I think. Jyoti?
Yes, ma'am.
Yeah. So I want all the parts to switch on your camera so that we can take some picture, and we will go for that validity function. And few of the participants who want to give their feedback, you can give your feedback, and then we can propose formal vote of thanks. Discuss. Okay. So please switch on your cameras so that we can have a picture. Jyoti,
Yes, ma'am.
did you capture a picture?
Okay, ma'am.
I request all the participants, please switch on your camera so that we can capture your picture. We didn't even ask you to switch on your cameras in all these 15 days. Right, last day, switch on your that we can.
తీసుకొని వచ్చి మనం మార్చుకోవాల్సిన పని లేదు. ఎందుకంటే ఆడిట్స్ ఉంటాయి కాబట్టి అండ్ మనకి ఆడిట్స్ మెయిన్ ఆడిట్స్ ఇస్తే చాలు కాబట్టి ఇయర్ వైజ్ ఉంటాయి. వాటి గురించి మనం ఫైనాన్షియల్ టచ్ చేయలేదండి. అకాడమిక్ మాత్రమే టచ్ చేస్తున్నాం. అవన్నీ ఫైల్స్ రెడీ చేస్తున్నాం. 22-23 అంటే ఇప్పుడు లాస్ట్ ఇయర్ నుంచి మనం స్టార్ట్ చేయాలనేది. అంటే ఇప్పుడు ఫస్ట్ సెకండ్ ఇయర్స్ ఉన్నారు, ఫస్ట్ ఇయర్స్ ఉన్నారు, సెకండ్ సెమ్ రాస్తారు, ఫోర్త్ సెమ్ రాస్తారు, వాళ్ళు థర్డ్ సెమ్ వాళ్ళు ఫస్ట్ సెమ్ అక్కడి నుంచి వాళ్ళు మొదలు పెట్టారు. అంటే కిందటి సంవత్సరం డేటాను కూడా వీలైనంత వరకు ఒక 10-15 రోజుల్లో నాకు ఇచ్చేది. కింద సంవత్సరం ఎవరి దగ్గర ఉంటే
You can make them attendee if they are not able to recognize that they are speaking to us. Make them attendee. So only few minutes, just 5 minutes, we'll have this validity function. I request the participants to give your feedback, please. Anyone about this 15 days? Gayatri, Padmaja.
Hello.
Yes, come. Please
Hello.
tell your
Hello.
name and your college also, and give your feedback.
Good evening, everyone. Hello.
Yes, we are able to hear you. Sir, we are able to hear you. Please proceed.
Good evening, everyone. Myself, I'm Balaji Tadla. Hello.
Yes, we are able to hear you, sir. Please proceed.
Thank you, madam. Myself, I am Balaji Tadla, assistant professor, working at Sheshadra Gudlavalleru Engineering College, Krishna district. Firstly, I would like to extend my gratitude to the organizers of this FDP session. This FDP is one of the best I have attended so far. And these 15 days training was so extremely valuable and useful to all the faculty, whoever they started their journey into PhD. The first thing for any PhD holder like me is choosing a domain and subtopic in it. So by attending this 15 days FDP, I learned around 10 to 15 various domains information, so it can help my path for choosing a suitable research area. And finally, the online training was well organized and followed the time schedule for each session. I enjoyed it. Thank you, madam. Thank you, sirs.
Thank you, Balaji Garu, for your kind words towards the FDP program. Thank you. Next, anyone? Please, any other person?
A very good afternoon to all. Ma'am, am I audible, ma'am?
You are audible, please proceed. Good afternoon.
I am Dr. A. Padmaja, working as an assistant professor and head of the department EEE in College of Engineering, JNTU Vijayanagar. And I want to, first of all, I want to congratulate and thank all the organizers, especially Jaisuma madam and Jyoti madam, for arranging this wonderful FDP of 15 days on emerging research trends in computer science and engineering. And this is the best workshop. I truly enjoyed all the sessions, which are designed so brilliantly so that all key areas of present research in CSC are covered. So various discipline, the participants from various disciplines, I'm sure that they can have an idea on choosing the areas of emerging trends in means the application of computer science in their respective research areas, and especially the sessions related to machine learning, augmented reality, and cyber security, and research paper writing. So all areas are covered very brilliantly. Ma'am, Jaisima ma'am, I thank you from the bottom of my heart for arranging this wonderful workshop of 2 weeks. Thank you so much.
Thank you, Padmaja. Even though you have belonged to EEE department and HOD, you have sincerely attended all the sessions. And thank you very much for gaining the insights of computer science and engineering. Thank you.
Thank you, ma'am.
Any other person? Any other one? Please interact or give your feedback.
Good evening, everybody.
Good evening. Good evening, sir. Tell me.
Am I audible, madam?
Yeah, audible, sir. Please proceed.
Yeah, Dr. Mohan Rao from Avanti Institute of Engineering and Technology. At the outset, I congratulate you, madam. Being a new university, it is a challenging task to take up a 15 days FDP, that too on prime areas, getting resources from very good organizations. Many congratulations to you. You made it highly successful. and it has given a motivation and orientation for all the faculty members. Even though I am busy in my administrative works, I have gone through all the sessions, and all the sessions are highly useful for the faculty members for taking up their regular classes as well as taking up research also. I suggest you to take up many more FDPs in the coming days, so as to useful for the teaching community of our JNTU GV. Thank you, madam.
Sure, sir. Thank you for your feedback. Thank you for attending the FDP program. Even though you're a principal of Avanti College, you have attended it and made it success. And in future also, we are planning to have some short-term courses. Whatever the areas or domains or programming languages or any technologies required by your college, please give me just a simple email so that I can get those type of domains into the picture of FDP programs or short-term courses. Thank you very
Sure,
much.
madam. Sure, madam. Thank you.
Anyone? Any other person? So whatever you have learned, please express. I think someone is trying to speak out. So there are a lot of challenges to organize the FDP program through online virtual mode. We are able to recognize in this program, and definitely when we are FDP or a short-term course training through virtual mode, we'll rectify those things. And I who have really given their insights and their expertise and sharing their knowledge regarding their domains been very well mannered. On behalf of Faculty Development Cell as well as JNTU GB, those persons and the participants for actively participating in this program. And I want to thank our administrators, university officials, especially our Vice Chancellor Sir and Register and other directors who has given their kind support in organizing this FDP program. Thank you, one and all. Now, Jyoti, please propose the formal vote of thanks. And
Okay, ma'am.
our team, we are, before it 1 minute. I was with Jyoti. She's working in IT department as well as she's my research scholar. And I have only 2 other technicians only in my department. So only 3 people really struggle to organize this FDP program. So I thank my team, that is especially Jyoti, Santosh, and Surya Mohan for assisting me to organize this FDP program, and it takes because besides this program and other things, we have our regular duties also. So it takes at least 1 week to issue the certificate. Please bear with that. And now, Jyoti, please.
Okay, ma'am. Good evening to one and all. First of all, I would like to thank today's resource person, Dr. Sirisha ma'am, for your valuable and knowledgeable session on deep learning. Definitely our participants gain a lot of information about this on the area of deep learning. Once again, my heartfelt thanks to Dr. Sirisha ma'am. Now, I propose a vote of thanks for today's final valedictory function. On behalf of the organizing committee, I would like to express our deepest appreciation to all those have made this a sounding success. First and foremost, we extend our sincere thanks to our Honorable Vice Chancellor, Professor K. Venkata Subbaiah Garu, and Registrar, Professor G. Swaminayudu Garu, for accepting our proposal to conduct a 15-day faculty development program. We are truly honored to you, sir. Sirs, we extend our heartfelt thanks in each and every resource person. I think in each and every day. Ma'am, please, 1 minute, ma'am.
Okay. Take your own time.
Okay. The first day, Professor U.S.N. Razu sir for delivered computer vision, and second day, Professor Ramdas Garu for delivering big data related issues, and third day, Professor Nagaraju Garu industrial IoT with 5G and role of 5G in IoT, and then day 4, Professor V. Ravindranath Garu, JNTU Kakinada, in the area of art programming, and fifth day, Professor Valli Kumari ma'am, Andhra University, on the area of cyber security, and day 6, Mr. K. Venkata Pramod Chandra, Wells Force India Private Limited. He gave the information about robotics and automation. And seventh day, recommending systems, Dr. Professor G. Lavanya Devi ma'am, and then day 8, ER and VR, Professor Damodar Reddy Garu. Day 8, writing high quality research articles by Dr. Janmanjoy Naik, MSCB, University, Odisha. And then day 10, blockchain technology by Mr. M. Sai Charan, NatSoft. And day 11, natural language processing by Professor M. Sashi, Andhra University. And day 12, Python programming, myself, RSS Jyoti. And day 13, advances in computing ocean environment, that is to be delivered by Dr. R. Venkatesan, Technical Consultant, NCCR, Ministry of Earth Sciences, Chennai. And then day 14, research towards AI, that is to be delivered by Professor G. Jesma ma'am, Director, IIIT NP and Faculty Development Program. And finally, day 15, deep learning, which is delivered by Dr. G. N. VG Sirisha, Associate Professor, SRKR Engineering College. So once again, I heartfelt thanks to each and every person, resource person. Our heartfelt thanks go out to the organization committee members, the faculty and the non-teaching faculty who have worked tirelessly behind the scenes to ensure the smooth execution of this program. Your dedication, attention to detail, and countless hours of hard work have made this event a grand success. And to the participants, you have shown exceptional talent, skill, and perseverance throughout this journey. Your passion and commitment have been truly commendable. Each one of you has contributed to the success of this event, and we are grateful for your participation. Thank you once again for being a part of this wonderful journey. May each one of you find success, happiness, and fulfillment in your path ahead. Wishing you all the best, all the very best. Thank you. Thank you, one and all.
Thank you all for
Dear participants, within 1 week, we will send your participant certificates with your registered mail ID. Thank you, one and all.
Thank you. Thank you, one and all.
Thank you.
Okay.